Hi everyone. In this video, I will use an example of a chord chart to talk about more advanced low-level approach to creating data visualization in Power BI. It works in both Deneb custom visual and core visual such as new card, table, and metric. What is special about this chord chart example? I was creating a set of Deneb templates based on Financial Times visual vocabulary. There are about 70 different charts in the vocabulary, and this chart is the only one I wasn't sure I'll be able to complete using Vega. The problem with this chart is that it requires this links between the chart nodes, and there is no mark in Vega and there is no data transform in Vega that allows us to create this carved link. There is a stan key chart which is possible to create in Vega using link path transform, but link path transform don't work well inside of a circular chord diagram. We need something else. I was looking for a solution, and I have found that someone used D3 to generate SVG images for these links in D3 and then just copy pasted SVG code into Vega. But it's a one-time ad hoc solution that allows to create a static chart not connected to a data set of Power BI. We need a solution that will work with dynamically changing data, not something hard coded and created outside of Power BI. And then I realized that I can use Vega expressions inside of Vega signals and some trigonometry, sinus and cosinus calculations, and SVG paths to generate whatever SVG paths, whatever carved links for the chart I need. Let me explain more in detail. In the description to this video, you will find a link to my GitHub repository with all the materials that I am demonstrating in the video. To create a chord diagram, we need to create this carved link. This is one of the links and explanations on how SVG path command can be used to generate this link. We are starting with M command, which defines initial point of the drawing. M command doesn't draw anything, it just sets initial point of our drawing. Then we use A command to draw an arc to the point 1. Then we use U command to draw a quadratic Bezier curve to the point number 2. Then we use one more A command to draw one more arc to the point number 3. Then we use one more U command to draw the final curve to the point 4, which is in this case the same as our initial point. And the Z command is just closes the path and joins initial point with the final point. In this case, it's the same point. Also, to create a chord chart, we will need this outer ring. Let me show you it here. The outer ring of chord chart is just a donut chart. And we have a way to create a donut chart in Vega using a pie transform. Donut chart example from Vega website explains how we can create the donut, which will be outer ring of our chord chart. But to create the same chord chart in chart visual using only SVG without Vega, we will need to create one more path instead of the Vega transformation. So to create this outer ring, or every part of this outer ring, we will need to use 4 lines, two curves and two straight lines. So again, M command sets initial point, then A command makes first arc, L command makes straight line, A command makes one more arc, and Z command in this case creates the final straight line and connects all the points into a single shape. This is how we can use SVG path command to create chord chart. More detailed explanations of all the SVG path commands used for this chord chart. So M command, once again, it just moves the pen without making any drawing. L command creates a straight line. A command creates an arc, and we need to define different properties for the A command because there are 4 different ways of how an arc can be created. We define axis x radius and axis y radius for our circle or ellipse, and then we can define axis rotation if it's not a circle but an ellipse. In case of ellipse, it's just 0, we don't need to rotate it. And then we use large arc flag and sweep flag to let SVG pass command know which arc we want to use. Because when we are creating an arc from initial position to the end position, there are 4 different ways to create this arc when we have radius and rotation position defined for this ellipse. It can be one of 2 small arcs, or it can be one of 2 large arcs. In our case, we will use both small arcs. We don't need large arcs. The next command is U, which draws quadratic Bezier curve from current point to the end point using a single control point, which defines how curved is this curve. And that command ends the path and, when required, draws a straight line to the initial point. So let me open the Deneb custom visual and show you what is inside. Inside of this Deneb visual, we have our data, names of source nodes and target nodes, and some values for the link. Again, I won't be showing all of the details of this Vega code because the main part of this code is just donut chart. So let me remove the final path mark from the code. And you can see that without this single mark, it's just a donut chart. And I assume you can create it. If not, you can visit Vega website and check also the example on the Vega website. And I will talk in more details about donut chart probably in my following videos about the net. This video is more advanced. I will try to create videos for different levels. Some videos will be about basic chart types. Some videos are going to be for more advanced chart types. So what happens in our Vega specification? The main part of how we are creating the link is this data link data table. So data link data table takes a data node source table which contains a list of, let me show you, data node source. It's just a list of all source nodes with start angle and end angle angles created by pi data transform. So it basically defines all these parts of the donut chart. Then we have data node target table with the target node. And data link table merges source nodes with the target nodes. So for every source node, let me open the data link table. Each row here is a source, and we have a path field here with the path and how we created this path. There is a formula data transform, and the formula is just a concatenation of SVG path commands and our x and y positions and radiuses required to generate all these lines and curves. So the command, I'm switching again to this explanation. This command, the sequence MAQAQZ command, is defined here in the expression for the path formula. So it's M command move to the first position, which will be a point here. Let me refresh it to make the link visible. The first point is here, then we make an arc to this position, then we make a curve to this position, one more arc, and go back, creating a link. And in the table, in the data link table, in the path field, we have SVG path for a single link, and in the table we have link for the entire visualization, and then we just use this path mark that uses data link table to generate SVG paths. For the path, it uses data from the path field in the table. And that's it. Really easy way to create highly customized visualization because you can use this SVG path command to draw really advanced visualization. I'm going to play with some flowers, various kinds of flowers, and so on, more creative kinds of visualization, not something I will use in Power BI for business reporting, but something creating that allows to explore new possibilities, and then many of them can be in various ways utilized in business reports. Like I was starting learning SVG, doing some silly things in the SVGs, and then when I learned SVG better, I started making IBCS style charts and other business intelligence stuff. So let me show another report where I created the same visualization, but using a new card visual. This is the card visual, and I created this report page that in detail shows all the components of the chart. It's just for the demonstration. The main chart is here, and everything else here is just for the demonstration. And let me explain. Here I have a list of Chord chart elements or all the links, like from egg fruit to banana, we have this link, which is here. And in the table, we have all the data used to create this link. So we have source name, we have target name, we have value, then we have total value, cumulative value required to calculate the position of the donut chart. Then we have angles for all the positions. So it's just a few DAX formulas. Let me show you. There is a measure for SVG which generates SVG code for the image. Initial section of this measure is for configuration. Here I just define some sizes, like the entire size of the SVG image, radius of the chord, radius of the outer ring, some colors, neutral color and color to highlight what items I'm going to highlight, and some additional configuration for the opacity and for the colors of the line. And the main section is this SVG code generator, which concatenates for all rows in low chord table all these calculations. You can see in the table that I have, let me, all of the rows. I have 20 links that I need to create, and I already have some angles calculated here for source start. Let's say here, for source target is here, and for source end is here, and for target end is here. 4 points we need for this element. And for every element we need 4 points. We have radius and we have angles, and it's enough to start drawing. I will go back to the DAX. We need for every link, we need to calculate 4 positions, and for every position we need x and y coordinates. So I have 8 variables here for every link. You can see some sinus and cosinus calculations here just to transform what we know, angle and radius, into x and y positions on the plot. And we need 4 additional positions for the outer ring, element of the outer ring donut chart. And then it's just usual concatenating to make M command with X and Y position, A command with radius, one more radius which is the same, a few additional parameters, X and Y position, L command with X and Y position, A command again the same, and Z command to close the path. This part is for the outer ring, for the donut chart, and the second variable is for the link. And then we add in some additional header, opening tag and closing tag, just to make a complete SVG code. And you can see SVG code of the entire chord chart here in this text box. Or you can select a single element and you will see a short version of the SVG code for this single element. This page probably will be useful for you to use during development of any other SVG visualization inside of a new card visual. You just can start editing this measure that generates SVG code, and you will see all the details on this page. I assume it will be useful. You will find this file in my GitHub repository. Again, the link will be in the description to this video. That's all for today. Like, subscribe, and there will be more interesting videos